Hey everyone, we're Skyler, Toby, and Andrew, and our networks project this quarter was Super Pac-Guy. The basic premise of the project was creating a cloud-based multiplayer version of Pac-Man. First, let's talk about the code. The project was written in Python. The first thing we did was build an application layer to allow us to network. This involved defining various packet formats and packet interpreter functions. The way we chose to go about it allowed us great flexibility in adding packets later on, and gave us clean, compartmentalized code. The gameplay code is an extension of the Pac-Man AI project which was developed at the UC Berkeley, with the primary contributors being John De Niro and Dan Klein. This code is used currently by the UW CSE 473 AI class, and provided the graphics and basic game structure, so that it would be possible for a single user to play a local game of Pac-Man as the Pac-Man character. We took this code and extended it so that it would allow for multiple players, meaning that some of the ghosts would be controlled by humans instead of the computer. We also hooked up the game code to our network code, so that moves typed by the clients would be transmitted to the server, which runs the main game logic, and that game updates would be sent from the server to the clients. This allowed us to keep the client-side code as simple as possible. Next, let's talk about what the actual gameplay looks like. The server is started on a machine, and clients can then connect to the server by specifying the IP address and port. There's a lobby in which the client can specify information, such as how many games they want to play and which character they want to play as. Once all the connected clients are ready, the game begins. The clients each control their characters in the game, and the normal rules of Pac-Man apply. Once all of the games are over, final statistics about the game are printed, and a graph of RTTs is displayed. We collected data from various scenarios. Our graphs show the RTTs for packets in red, and the average time it took the game to go through one iteration of its main loop in blue. The main loop involves getting each client's move, updating the game state to reflect that, and sending the updated state to every client. First, let's look at a single-player game on a local network. The key thing to notice here is the difference between the Ethernet on the left and Wi-Fi on the right. It is clear that with Ethernet, the variance in RTTs is much lower, as would be expected. Next, let's look at a multiplayer game. This game was hosted on Skyler's server. He was on Wi-Fi on the same network as the server. Toby was 5 to 10 miles away and using Ethernet. Andrew was 5 to 10 miles away and on Wi-Fi. Once again, a clear difference in the variances between Wi-Fi and Ethernet can be observed. It's also clear that Skyler's average RTT is much lower than Andrew's, which is to be expected as well. Finally, let's look at some long-distance games. We ran a single-player game with the server based in Japan. Comparing the average RTT of this game with the average RTT of the previous game, it's clear that the RTT has increased significantly due to the greater distance. We also ran a game from Ireland. In our presentation, we had an RTT that was physically impossible, but this turned out to be an error in how we were calculating the RTTs. Once we fixed that bug, our numbers are much more in line with what is to be expected. Overall, we found that the RTTs were greater than the amount of time it took the game to run one loop, but as we set up the game on an event-based model, it's more likely that the limiting factor in performance was the game itself. As it was written in Python and uses a graphics library not known for its performance, it's not surprising that the game can suffer lags when multiple people start playing, especially since the original game code was not designed to be used over the internet. If we were to build this project from scratch, and we had more than 5 weeks to do so, we'd probably use a language like C++ and build the game from the beginning with an understanding that it would be a network game, allowing for much greater performance. Overall, we enjoyed working on this project and feel like we learned a lot.